Hello, hello. How's everyone doing today? Today we are going to be making a browser use agent. But before I start, I just want to see how everyone's doing. Send me some love in the comments. Also some love for the TAs. How's your day been so far? Did anyone get to mess around with the code execution agents that we learned how to make last time? Let's see. I think we have a group of people watching. I don't see this. Oh, there it is. Yeah, okay, we got 4 or 5 people just joined in from YouTube. Wait for everyone else to join up. So let me make sure I did the right URL there. Yep, good. Okay, so hey guys, how you doing? Today we're going to be making a browser use agent. Hey Raj, there he is. Cool. Good to see you. Yeah, today we're going to be making a browser use agent. So basically, we're going to be making an AI agent powered by LLMs that uses a fully powered web browser. So we're not talking about just scraping HTML from a website and then passing that into an LLM. No. What we're going to be doing today is we're going to be using a fully featured Chrome web browser, and we're going to be automating that with an AI agent. The reason why it's so important that we're using Chrome web browser is, as you know, the web has changed a lot in the past 10, 20 years, and now everything relies on JavaScript. And the DOM, I think that stands for Document Object Model, is that right? The DOM, yeah, the Document Object Model, which basically means the web pages are generated dynamically on the fly, and reading the HTML of a page isn't going to get you very far. So let's just have a look at an example real quick. I want to go to the google.com. I want to go to the google.com homepage, right? So let's say we wanted to scrape this page. We wanted to pass it to an LLM to understand what's going on here. Well, let's look at the source code of this page here. So, gosh, I don't know what's going on here. This is pretty crazy, but maybe an LLM could, right? So let's first see though, like, let's go to character counter and see like how much data is in this page. And keep in mind, this is just one file. There might be other parts of this web page that we haven't linked to. So this is 200,000 characters. Okay, just for this. You know, back when the internet first started, this would have been like a couple hundred characters. But that just shows you how much information, hey Nelstar, good morning, goes into a single, the loading of a single page. And that's just one page. If we look here under like all of the things that are being loaded, there may be other important files, JavaScript, HTML that's getting downloaded. We can see them here. That might be important. So we cannot get very far just by scraping the data from a page. And even if we could, it would be way too much to pass into an LLM, because if we look at like let's look at Llama 3.2 token limit. It's only, you know, we're talking thousands of tokens, maybe 10,000 if you get a really powerful. Hi, Jordan. Thanks for joining. But that's not going to be enough, and it's just going to be completely overflowed by passing in the data. So we need to be clever, and so what we're going to do today is we are going to be actually giving the LLM agent power over a web browser. And the way that I've thought of doing this is the way that everyone is automating web crawling today. I mean, everyone who has a serious web crawling task. And that's using, there's a couple of libraries, but the main library is called Playwright. And by library, what I really mean is it's a system. It has a library, but behind it, it has a whole web browser. People used to use Selenium for a very long Selenium headless browser, and then for a long time. So and then there was Puppeteer, which is quite popular as well. Puppeteer only was limited in which browsers it could support. Now Playwright is really popular, but what these are is they're web browsers that you can run from code without needing to actually even have a screen. So the code can operate the browser just like a human would, but it can run in command line. It can run in Python. So the first step of making our agent is going to be to get Playwright running in a Colab notebook. So let me share this notebook with everyone. Let's pass that in the chat. There we go. And I was actually happily surprised to see that there were no issues at all if I tried to run pip install Playwright in the Colab notebook. And by looking here at the docs, somewhere around here, if you look at the installation, you will find a second command that we have to run. I have no idea where it is here, but the second command that you have to run in order to fully install Playwright is we have to install the web browser, because Playwright is just a system that works with various web browsers, which is what's really cool about it. But we're going to use Chrome. So Playwright install with deps Chromium. So that should install. Now Chromium isn't Chrome, it is the open source browser that Chrome is based off of. But as far as like a usability perspective, as far as the purpose of scraping websites, basically we're getting the same thing. So I just ran these two commands: pip install Playwright, Playwright install Chromium, and we're installing the browser into this Colab notebook. So yeah, go ahead and do that because go ahead and do that in a Colab notebook, because it's going to be really fun what we can do once this is installed. We had a great question here from Curious Coder. Said they missed the past two tutorials. First of all, great to see you again here at the class. So today you'll be able to follow along if you hang on, but I really recommend that you at least watch our session on building a React agent, and our session on tool use, on LLM tool use with JSON. If you haven't watched those, you're gonna be you're gonna have to be running to keep up today. Hey Harsh, because what we're making today is a powerful agent in 1 hour. So we're gonna be moving pretty fast, but feel free to try and keep up. And for things that you don't understand, you'll probably have to refer back to the earlier lessons that we've done. Hi Harsh, great to see you. How's your vacation coming along? Great. Yeah, so we're going to be using JSON tool use for this one, assuming we make it that far. Um, yeah, we got a lot to do today. So the first thing is we're gonna be just seeing how you can even use Playwright to begin with in the browser. Sorry, in Colab, which is um, a library that connects you with a headless browser. Cool. So to use Playwright, we just do from. I shouldn't say just. It's actually kind of strange. So they have an asynchronous API, and this is the example that I found that worked well for what we want to do, called the async API. And what that means is that when we call Playwright, we are going to be using the await keyword here in Python. So p equals, we are going to be creating, await is for async, and p equals, we are going to be creating a new browser object. Okay, so async playwright dot start. All right, and that doesn't create a browser, but this just starts Playwright. It sort of starts the thing running, and then to create the browser, we can run await p.chromium.launch headless equals true. What does headless equals true mean? That means that the browser doesn't actually show anything. Here it's Colab, so it's a headless environment. But if you would run this on your local computer with headless equals false, you'd actually see the browser open and then start automating itself. This means it runs in the background. Don't get too fussed about the syntax here. To be honest, this is all quite new to me as well. Even it feels new, even though I've seen this stuff before. I'm just going to walk you through the commands you need to use it, you know, the docs are always there for later. And we need to create a new browser context, browser new context. So that's something that we can actually open tabs and pages in, and then we're going to create a new page, which I believe is kind of like a tab that we have open. So all that done, we can actually use Playwright. Let's see, let's get it done. New page. There we go. Cool. Great. So once this whole chunk of you know, of code, boilerplate code is written, actually doing stuff with Playwright is really easy. Okay, so to actually load a page with Playwright, all we need to do is await page.goto, and let's go to Amazon.com. Okay, now since there's only one command here, I don't really need await, but if you don't put await, it will run the next command before this is finished. And so that's why it's important to be using await, because we're dealing with things that happen, steps that happen, you know, one after another with this agent. So let's run that. And so if this worked, there's an invisible browser right now in the Colab notebook, which has a Chrome-like browser, which has Amazon.com up and loaded in it. And so what we want to do is we want to, well, let's have a look and see if it worked, right? So I have this code here for taking a screenshot, okay? So that's screenshot equals await page dot screenshot. Cool. And let's run that. And does that save it to a file? I think you can do file name equals amazon.png or something like that, or file. but we're actually going to save that into just an image, and we're actually just going to display it here in the Colab notebook, which is going to be better. So we can use like basically some image libraries in Python. Here, I'm just going to autocomplete this. That's going to allow us to display. It's going to allow us to display the image here in the notebook. So this code is like kind of awkward, but let's import these libraries. Fortunately, Colab knows what we need to import, and let's run that. Okay, cool. Oh, great. We got the CAPTCHA. So that's gonna be a huge that's gonna be a huge annoyance. And when I ran this, so it's working, the browser's working, but it got blocked. It got detected as a block. When I was running this yesterday, this example, I didn't hit any captchas. So this is just something that you have to be aware of, and I can give you some solutions actually for bypassing captchas, and stuff. They're not bulletproof, but yeah, that's something we could talk about later. But for today, let's just try a different website that might be easier to automate. So who has an idea for what's a website that we could try and crawl with our agent, that's not Amazon, and preferably not Instagram or LinkedIn or any of those, because they're all going to be really difficult. Berhan, you got any ideas? Research papers. Oh, there's an idea. A news website. Okay, so we have two ideas. We could do something like, how do you spell it? Archive.org. Oh, Pinterest. That's a, Now that's an interesting one. Pinterest would be great. I'm actually curious to try it. So this would be cool. Archive.org, for research papers. Um, Raj said Indian e-commerce. Okay, what's an Indian e-commerce site? That would be fun. Um, I try news, but as an American, I don't really want to look at the news today. So let's do something else. And um, um, Indian e-commerce will be really interesting. And then Pinterest. That sounds fascinating. Can you use Pinterest without logging in? Pinterest is cool. Let's see this, and let's see if it doesn't get blocked. So let's do it again. Okay, and run this again. Okay, Flipkart, they say, is the... Oh, interesting. So it looks like, so we did Pinterest. Okay, Flipkart, that might be another one to try. Okay, Pinterest is, let's try Flipkart. Tesla website, it's a great idea. Yeah, Flipkart, yeah, I could try it. These are great. So I want to see, by Friday that all you guys have gone and made agents that are working on these websites. But so for this, it looks like maybe it didn't load completely. So you saw that I ran this and then I ran this one right away, and the page hadn't loaded completely. So this await here doesn't wait for the page to load. It just waits for the page to start loading. And then if you want to wait for the page to load, there's actually another command that you can use, which is page dot wait for load state. Okay, so that's one type of load. And then if you want to wait for like the page and all images and everything else to load, I think you can do, there's one called, so there's different, web browsers are not simple things. There's different types of loading and different ways to decide if the page is finished loading, but then you have these different states. This one would be this one would be like it's basically loaded, and this one would be like it's completely totally loaded, the network idle one. So yeah, Pinterest looks pretty good. I really like the Tesla example. So let's try the Tesla website. Oops, what's the Tesla? Let's try this. Is there like a ton of images or something on this? Might not be the best. Okay. Looks like that caused it to slow down a bit. Let's see. So when that's finished, and here, let me do something really quick. Let me make this this screenshot. Let me make this screenshot a bit. Okay, this one timed out. So I don't know what caused it to time out, but that could also be bot detection. You never really know. So let's go with the Pinterest for now. And I'm going to do something real quick. I'm just going to make this here this image smaller, just to, and I'm going to do image.resize the times 0.5 each way, because I want it to show up better for everyone here. What have I done wrong? I think this has to be, oh, int. These have to be integers, I believe. Okay. And then I have to do, did it make it smaller at all? Image.size, image.resize, 0.5. I don't think it did. This worked for me before. Let's see. Image.width-height, image.size, image.resize. Does anyone see what I did wrong there? Let's see. Anyone in the chat? New width equals there. New height equals. Let's break it down just to make it clear. And there. Ah, okay. Something slipped my attention there. So that's like a little bit easier to see what we're dealing with. So we got to keep going. Someone says you need to install an image package to make the image display work. I don't think you do. I think these are all coming built into Colab. But if you do find out something like that, let us know. Because I haven't. This is a fresh notebook I just made. Oh, you're getting import is failing due to a missing package. What's the package that's missing? Let's see. Or it's possible, just check these very, very carefully. IO, PIL, and IPython.display. Check those library names. So basically, we are going to find a way now to get the agent to click on stuff. Okay, so there's so many different ways to attack this problem, right? We can look at the screenshot. We can look at the contents of the page. What we're gonna do just to start out, this is the simplest way I can think of, is we're gonna do a search on the page for all of the links and buttons. Okay, because when you are on a page here in your browser, you actually have, this is interesting, so you actually have, I can't open it. Let's go back to this page. Pinterest is a very strangely designed website. So let's go back to Flipkart. So here, so when you're on a website, your browser has information about, close this, information about all of, if I right click here and then I do inspect, my inspector is not coming up for some reason. It's quite strange. So here you should be able to see, something's running a bit slow on my computer. Let me close some stuff. Close Spotify, some other things. So here you can actually see that all of these elements on the page, the browser is aware. That's cool, right? Aware of every item on the page individually. It knows where it is, and it knows what text is inside of it. Now, there's a ton of elements on the page, right? Here I can see like inspect this, and it will bring me to that item specifically. Cool, right? So your browser knows all this, but there's so much going on. We can't just feed all of that into the LLM. So what we're gonna do is we're gonna do a search, and I'm going to use await page.query selector all. This feels like a throwback to the jQuery days in JavaScript, but basically this is a way to search through all the elements. It's probably thousands of elements on a page, right? So let's get A stands for anchor. That's a link in HTML. And let's get the buttons. And here's another way to define a button. And anything that has on click. These are 4 different ways in HTML to define something that can be clicked. Okay, so what this says is search the DOM of the page for anything that can be clicked. Okay, and return back, let's see, 45 different items. Okay, and one of the benefits of doing this way is that it searches the entire page, not just the screenshot, not just the part of the page that's visible. All right, so so let's by the way, thanks Mixer Canada for checking my code. So basically we are going to look through this list, and we're going to get the text or the labels for every item that can be clicked, and then we're going to put that in a format that we can actually show to the LLM. So instead of giving all of the code to the LLM, we're just going to give like a concise list of items. So let's do a for loop. Let's put this into a variable. Call it clickable elements. Okay. And for each element in we're going to enumerate. So we're going to loop through all of these elements that we just found. We're going to print the text inside of that element. So let's see how that works. All right. Okay, this is interesting. So these are basically all of the links that were found on the page. Okay. And let's see which of these were buttons. We can do it like this. These were the buttons that it found. Let's try everything that was on click. Nothing. And let's look for all the actual hypertext links. Like this. Okay, so these are all of the links. We're gonna combine those all together. into one list. And let's see if we could also use some labels as well. So there's something called there's something called ARIA labels in HTML. And those are sort of like accessibility labels. This is optional. I would say let's just leave this out for this point. Let's just use the text. And let's only use the ones that actually have text. So if text printed, text. Okay, that's better. Yeah, that's pretty good. So I see this one here has a new line in it. That's gonna be a little bit confusing to work with. So let's take out the new line. Okay, let's say clean text, and then like a way you can do that in Python is by splitting the text and then joining it again with spaces. Splitting splits by new lines and spaces, and then joins it by whatever you put here. So if we run this, it should remove that. And then I print clean text. It should remove that that space, that extra new line. Have I gone too fast so far? Is there anything that that you want me to go back and explain again? I know this is a lot of like HTML stuff. Yeah, it's just arbitrary stuff that you'd have to go look at the details of how HTML works. But basically, this is a way to get all of the clickable things from the website in a very minimal amount of code. Okay, great, Jordan. Looks like people are still with me here. Cool. So this is important because this is going to be the main tool. It's going to be used by the agent that we're building. So let's put this, we could probably pass this directly we could probably give this directly to the agent just as it is, and you know, see what it wants to do. Or we could do it as like we could do it as sort of like a dictionary. Let's do it the dictionary way. So let's call it clickable labeled elements equals, and then I'm just going to make an empty dictionary, and then for each of these I'm going to add it to the dictionary instead of printing it out, and then I can print the labeled elements. Let's use pretty print so it shows it in like a way that it's not all in one line. Let's try that. Okay, this is the same thing, but now we've kind of put it into a JSON structure, which may be nice to have. So now let's see how we can actually click on one of them. This is where it's going to be getting fun. So as we saw before, we can run this again, just make sure that the web browser is still there. I don't know, it might have timed out. So this is still working, right? And if we look here, we see like, okay, watch, explore, shop, about, business, blog. We could actually find a way to highlight one of these using Playwright that would actually like put a box around it. But yeah, for now we're just gonna do something really simple. Let's click on explore, right? So the reason why I'm using numbers is maybe there's multiple things called, let's say, explore. So the numbers would be helpful in that sense. And another thing that's useful about this format is that it doesn't show in 2 dimensions where things are to the LLM, but it does show in 1 dimension. So things that are next to each other on the page, they may show up next to each other here, and that context could be helpful for the agent. So anyways, let's click on explore. So I will do, what did I call it? Labeled elements 3. That was the one that we needed. Oh yeah, and that was, sorry, this is for the labels. If we want to get this one just has the labels. If we want to get the element itself, I need to use clickable elements. A better name for this would be element labels. So this is called JS handle. What that means is it's a handle. The headless Playwright is using it as a handle to hang on to where something is in the page, so we can always find it in the browser later. So if I would actually do, you can see here it's kind of got some of the HTML code representation of it, but if I do click here, better to put a weight here. Now, let's see if it worked. Did it work? Not sure. Let's run it again. Okay. Okay, it worked. So what have we done? We've just loaded a web page into Playwright, completely in Colab. We have a headless, so aka invisible browser running inside of Google Colab, and we found a way to load URLs into it. We found a way to scrape the contents of the page loaded into the browser, to filter through those contents by certain criteria, and then to actually do things with those contents that we found. So click on them. And this is all stuff that we could automate using an AI agent. So let's go ahead and do that. So let's go to the OpenAI tool use example. It's called function calling here. And not using OpenAI, we're using open source LLMs, but fortunately, they're all kind of using this same API format. So this is Python, that's great. And I will do like this. First thing I'm going to do is change out the model and the base URL. So we've been using recently, what have we been using? I think Together AI as the host, but there's a lot of great serverless hosts for these open source models. So if I just paste in here the Together AI base URL and the API key, which is set up here, which I configured here into Colab. And you can do this easily yourself in a couple of minutes just by going to together.ai. You can also use, what other providers do we have? We have used OpenRouter. There's also Grok. Yeah. So you can use a number of them. And I use this one for this class because you can get started for free. So then, of course, this one is for open source models. It doesn't have GPT-4o. So we want to change that to, you find this by looking on the dashboard, but you can find it like this. This is their identifier for Llama. And that should work, not for our use case, but for this example use case they have. And this is a use case for a agent with a single not an agent, but a tool call. So a single tool call where you ask the LM a question, and if this tool call, the get weather tool call, is useful, instead of answering the question, it will say, I want to call this tool. But if I say just in what country is Paris, hopefully it won't use the tool call. It did use the tool call. So that's the important thing to note. Looks like the way this is set up, it will use the tool call, and that's something we can that's something that we can work with. That's not a problem for our use case. If I say, okay, so here, and so here, this, I just said hello, so that I shouldn't use a tool call. But then here I'm just printing the tool calls that come out of it, right? But if you print the content of the message as well, you should also get this, right? Okay, cool. And then let's try that one again. Where's Paris? Okay, interesting. Okay, so it's really eager. And this is a really interesting thing about tool calls, which we didn't really touch on much, is like one of the hardest things is for the agent to decide whether or not to call a tool, which tool to call is really something. In the open source models, unfortunately, their performance is a little bit worse than the other models, than some proprietary models on doing this, but they're catching up. But it gets the idea. It should work for this use case. So let's think what tools we want to give it to accomplish an arbitrary task browsing the web. I would say we should have one task, which is to load a web page. Okay, so let's say load page. And the description for that will be go to a web page. And the parameters there needs to have a URL property, which is a string. Okay, I think we'll be fine without the description for that. And the URL is required. And this is the pretty obtuse, very verbose format for tool calls that's standard today using JSON schema, which we learned about 2 lessons ago. And let's give it one more function as well. Let's say click selector, or let's just say click element. I think it's a bit simpler. And click on an element by ID. Now we're going to provide it the IDs of all the elements first before it makes this decision. So yeah, and it needs to have the ID here, right? So let's call it element ID, and this is a number, and this is required. Okay, so that should work. Okay, and then if we should change this to something like go to Pinterest and find some interesting. We were on Pinterest, right? Find some interesting images. Let's run this. And the first thing it decides to do is load the page, Pinterest.com. That's a good start, right? Okay, so let's now write the code that takes this tool call and actually connects the output of the LLM to actually run the tool call, right? So we've done this all before in the second lesson. We need to define a function for actually loading the page, and we've already written the code up here, right? So I'm going to define this function here. So def load page. Let's see, is this what I wanted? Yep, that's the same. This, I would rather do await here to be safe. And for the click element, this also looks pretty good, but I also want to use await here, as you should properly do when you're dealing with asynchronous functions. And that's pretty good. We're missing something. It still doesn't have the information about the elements that it wants to click, right? But let's add that in a minute. Let's write the code that actually creates the agent decision of what to do. And we can go back to our little flowchart here, right? So, oh yeah, we had a question. We had a question, is the that should work parts of what you are saying due to finding proper syntax or due to finding how to prompt the LLM? That was a minute ago. I said that should work, I think, when we were talking about something to do with defining these functions, right? When I say that should work, that roughly means that it's more about prompting, really. A lot of this stuff, if it doesn't work initially, you may just prompt it slightly differently, and then it starts to work better. That's what I was referring to. However, as I've seen before, actually, if you do the syntax wrong here, and I have, it actually doesn't always give you an error. Yeah, which is bad. You may get, the LLM might just stop working, and then you look back and you see you did the syntax wrong. So that's something to watch out for. Now, we're almost there, guys. We almost got our web crawling agent, and we're running up towards the end of the hour. So let's see if we can get it done. So let's take this output here, right? Let's put that into a variable called tool calls, and let's check if there are tool calls, right? And then if there are, I'll say tool call name, and it should be like this, I think, right? Tool calls, the first, we're assuming there's only one tool call ever coming at one time, and then we get the name of it. And if that name is load page, then we are going to be getting, it's all here in this format, but if you look closely, you can see the arguments are passed in this JSON string. We have to extract this out and then parse it. So that's what this is doing here. And let's see, eval, I don't like to use eval with untrusted code. So let's do import JSON, and then we should be able to do JSON.loads. That should work. Okay, and then instead of this is just parsing this string, right, to get this URL out of it. And then once we get that, we can load the page. Oh yeah, I was about to make this diagram, right? So this is the one we had last time for the code extractor. Let's just make a new one. So we have the LLM. We start here, and we pass in the tools and the tools, the prompt into the LLM, and we get out either an action or not an action, right? And if we get an action, so we need to actually check any tool calls, right? And then depending on the tool call that we get, we can do one of two things, right? We can either load a web page, or we can a little arrow, okay, or we can click on an element, right? And then once that's done, then we want to go back here. Keep in mind that every time we do something, it gets added to the agent's memory. So when it gets here, it's not starting from scratch. It's able to make a new decision based on the past things that it's done. It's a little ugly here. I don't know what's happening. But basically, and then finally, you get to a point where there's no tool calls, and it's like, I'm finished. And then if that doesn't work, you can also, there's also a little trick where you can give it a tool call which just says finish, and then that's another way to end it. So that's the way that I do it sometimes. So hope that makes roughly sense to everyone who's watching. And now we're going to implement that. So here we've started to implement this decision here, if there's any tool calls, right? And then which tool call there is. The other one is gonna be, and we've done this all before. The other one is click element, same thing, read out the element ID, and then click the element that we define in this function. Now the one thing that we're missing is probably the most important part, is this code that passes to the LLM the list of elements that it actually has available to it, right? So let's take this here, this code that we wrote before, and let's make another function, okay? Get clickable elements. And what this is going to be is just a function that returns, let's put this into a string, okay? It returns the list of elements on the page, okay, with their unique IDs that we've just defined. So now what I want to do is I'm going to insert here. Gosh, this is kind of ugly. I want to fix it a little bit up. Oops. Here, let's move this over. Great. Okay. Can everyone see that? Okay, yeah, and I just want to take this one, something like this. It's just slightly better. Okay, good enough. I want to insert here a new block that says find all clickable elements, right? And I want to do that actually, there's no point doing it before it's loaded anything, right? But we could do it always after it's loaded a new page, and then always after it's clicked on something, because then the page might change. So then you want to find all the clickable elements again, right? And then you want to do this again. Does that make sense? Another thing that's important here is wait for a page to load, because otherwise your clickable elements might not still be there by the time the LLM finishes its decision. So let's add that in here, and let's just do it like this. Instead of returning that, we can return this. We can return the list of clickable elements, and we can do that both times. Okay. Now, I'm not sure, 100% sure this is going to work. Oh yeah, and then we should also add in, here the LLM chat history, right? So we did that previously, because here this is just doing the same messages every time. So let's call this the chat history, and pass that in like this. Now, anytime, so let's run that. Now, anytime that we actually take an action, we want to actually add the output of the LLM to the chat history. So that would be, I want to load the page pinterest.com. And I also want to, of course, add the output of the action of the tool to the chat history, right? So let's do that like this. Let's say chat history dot append. So this is a chat message, and then it should be something like exactly like that. So this tool was called, and then this is the output of the tool. It's slightly different format than we had last time, but I think that should work. I believe that should work. Okay. And what I mean is this format sometimes they have like a tool ID here, but I think that might work without it. So, because it's all just JSON that's getting passed into the LLM, we can try anything. So that should now have the chat history. So the LLM has a memory of what's happening. One other thing that I want to add here is probably just give it a little context, saying the page has loaded and the following elements, IDs can be clicked. I think that is an important prompt to make, just to show, just to prompt the LM a little bit what its next step, and that to point out that these are the IDs that it can pass in the next step. So we have this now, each block of this implemented. Wait, no, I forgot this part. Wait for the page to load. Got it checked. So we had that code up here before. Page wait for load state. Let's do that. Let's do that here. Before we get the clickable elements, wait for the page to finish loading. And you always need to have async functions to call other async functions properly. Well, someone asked, what part of this new paradigm, coding AI agents, do you find most challenging compared to regular coding? That's a great question. I'm going to assume that by regular coding, first of all, I'm going to make an assumption what you mean by that. I think you probably, maybe like full stack, right? And I think it's a lot less about coding than it is about just thinking of workflows that make sense. You know, the way that I have designed this agent here, is I just thought about a very, very simple way that a person could use a website, right? You would go to, you can go to a website, you can load the URL, then you can click on things, and then you can click on more things based on what you see on the page. So I just think about it, the way that a human would do something, and then I just write that up as a loop in code. And at the end of the day, you're just making loops, like you said. You're just coming up with diagrams like this. And I think that when you put it into a diagram like this, and I saw this on the first day of this class, like this was way clearer to people once they saw it like this. So I think it's very different than coding. It's automation is what it is. You're taking a task and you're finding a way to automate that. So this is something that's been done for a long time using bots, scrapers, crawlers. I mean, how long has Googlebot been around, right? Crawling the internet. The only thing we're doing is we're inserting an LLM into it. So it's different, but it's fun. So let's run it all. Okay, we have get clickable elements. We've defined the functions, and this is the code that should check which function needs to be called. Let's run it. I hope this works. Okay, I didn't put any print statements here, so let's print the chat history. So let's pretty print it. There we go. So let's see what's happened. All right, so I made a little mistake here. Looks like I need to also put a weight here, right? If you don't use a weights properly, then weird things will happen, right? And then I also need to add, I should also put that here. Where is it? Here. Wait, okay. Just to be clear, I'll put this, this is the result or the observation as we called it in the React agent, right? Oops, like this, result equals, okay. Okay, great. Here, result, okay. And let's start from the beginning now. With the fresh chat history. We got some errors from Playwright, but it's still running, so there are more warnings. Now this has already been defined. We run this. It's deciding which tool to use. And I didn't put any print statements there. But as you can see here, from the chat history, the user said go to Pinterest. The LLM said I'm going to use the load page tool. It's all the way. Oops. Trust me, it says load page there, and it gave the URL of the page that it wanted to load. We went ahead, we checked that. We then went ahead and actually loaded the page using the function we defined. Then we returned back some options on the page that it could click, right? And we said, the page is loaded. Now, the idea to make the agent is to close this loop, right? So we're going to take this this bit here, right? And we want to run it again, right? So let's put this in a separate block. And let's run this again. Okay. It comes back with another tool call. This time, the tool call is, trust me here, it says click element, okay? And here it's given the ID of an element that it wants to click. Okay, so let's look down at the chat history, and we have 3 is explore. That's cool. We didn't tell it to click explore. We just said to find some interesting images, right? And now let's execute on that decision, right? And we got an error because for some reason it says that this element is not visible. Yeah, I got this before, but I was able to fix it. So one thing that I just want to check is let's check the screenshot. Make sure the screenshot checks out here. Okay, the screenshot still checks out. And let's do something up here. Let's make sure that all of the elements are actually, in fact, visible. Okay, so let's say here if text and element dot is visible. Okay, and I need to actually put this in the new function that we have below. And let's start over and see if that fixes anything. Okay, let's start with a fresh chat history. Okay, so go to Pinterest. Okay, and run this. It should be loading the Pinterest page right now. Oops, this was never awaited. Okay, that's an issue. We need to await this. Okay. Now, start over. This is the only thing that's quite annoying about agents is you have to sometimes you just end up with a large program that you're running over and over again as you debug. And okay, here it says element is not attached to the DOM, and I got this before, and it seemed to solve it when I actually checked if the element is visible, and when I ran this code here, this one, okay, let's run it. Okay, yeah. So let's just, I think I might have made a small mistake in the code. So let's look here. Yeah, I made a mistake, and I made this mistake yesterday, and it's a very small one that has huge implication. Let's see. I think. Yeah, it does. Does anyone see my mistake? This is not an agent mistake. This is a Python programming mistake, and it's on here. So I won't tease you too much, but this is the kind of thing where I really hit myself, or I really have to hit myself. So here what we're doing is we're finding the elements on the page, right? And storing that list into clickable elements, right? And then here we're using that, right? We're using that list. What's the issue here, guys? Scope. Problem is scope, right? You can't just create a variable in one function and then use it in another, right? So here, and now I have to create it here, right? Is this a list? Yeah, this is a list, right? And then I need to define that as a global variable, like that. So basically, it wasn't using the one I had created here. It was using the one I created all the way up here. And the funny thing is, I made this mistake yesterday too. So that's funny. So let's do it again. Let's start from the top. Fresh chat history, just with the prompt. This. Yeah, you're right, Mixer Canada. Everyone's so quiet in the chat these days. But I hope they're just entranced by the development that's going on here. The development's going on the screen. Yeah, see, Jordan's paying attention. Nelstar says he's enjoying it. Immersed in the learning. That makes me so happy. Okay, so, and we're almost finished here. So this is the most exciting part. So we've gotten the first step. It's loaded the URL. It's now got the list of possible elements to click on. So now let's run the loop. We're running the loop manually. So let's run it one more time. Here, let's see what comes out. Okay, it wants to click on element ID number 3. I really hope this is gonna work this time. Let's see. We got a list index out of range. Okay, I definitely made a mistake with the variables above then. So we have we're using clickable elements here, right? Clickable elements is this. Let's look at clickable elements. Let's see what's inside there. Oh, okay. Yeah, I did something wrong here. Let's make this a dict instead. I'm just thinking this would be a better solution. We have clickable elements and we have loaded elements. Oh, maybe I need to run this again. But let's just run one more time and watch carefully what happens, because this global should be getting written here, and then we should have this. This should not be empty. So let me just run that one more time. We have here, here, here. Now it should be empty. Now we run this. Right, this load page gets run, and that should call this, and it should update this, right? Okay, it did update this time. I think I forgot to update a cell. I think that's what happened, guys. Nothing to panic about. So let's go back, run the loop one more time. Now it's decided to click on element 3. Okay, fingers crossed this works this time. And it's doing something. Okay, something happened. Okay, cool. So it first loaded the URL. It saw what was on that page. It decided to click something, right? The Explorer, it decided to click Explore, and then it decided to, and then now we can see what's on this page. Let's just show the screenshot now. Now we're on the Explore page. So we did all of that. This agent did all of that, and it can go many more times in the loop, just based off of this prompt. Go to Pinterest. This was the prompt. Go to Pinterest and find some interesting images. Right? We didn't tell it what URL to use. We didn't tell it what to click. It's done that. And the next step for all of y'all is going to be to put this, like we've done in the first and second lessons, to put this into a complete loop, okay? And just the only catch is that your loop needs to have, you need to make sure that it ends properly. This should work in theory. If we put this into a loop like we've been doing so far. So we do it like this. We take this and like this, put this into a while true, right? And then if there's no tool calls, then break, right? Should we just try it? I have to put the prompt at the top here too. This should work. I have no idea. I haven't tried this yet. So, also there's no logging. So now we're in a dangerous place. Let's see. Okay, we are logging the tool calls as they're coming along. So it loaded Pinterest. It clicked on an element. And probably it's going to click on something else. Okay, it clicked on something else. And then after that, it decided it was finished. And let's see where it ended up. Now keep in mind, the only thing that it can see right now is this list of links and things that we've given it. The next step would be to make it actually able to use more useful information like from the page. We could take the screenshot and we could also pass that into the LLM as well, because we're dealing with, this is Llama 3.3, right? But if we would change this to be Llama 3.2, okay, change this to be Llama 3.2. Where's the models? Okay, so this should work. If I can sign in here, let me go to models. We need 3.3 doesn't have vision, okay, but 3.2, this one does. Okay, do we have a free version? No, 3.2 isn't free, but you get some credits to start out. Okay, so we can take this. We could put that in instead. Okay, and from there on, we could actually go on to pass in, for example, right, where were we doing this before? We were doing this in the function definition here. We could actually, instead of returning like this string, we could also return an image as well, and you can actually encode that image and you can pass that into the agent to give it more information. Or we could take just the text from the page and pass that into the agent. This would be probably the next step. I'm not going to do it today because it's just going to take more time. But I think for just over an hour, we got really far. So the challenge to everyone who's watching is take this agent that I've made. I mean, of course you can make it from scratch, but you can also just take this code, improve it, because it's really rough right now. Improve it, um, make sure that this loop really works properly, that it's actually like stopping at the right time, and it's actually like able to kind of solve a couple of basic problems, you know? Maybe clicking through a website. You can also add more actions as well. We just load page, click element, but you could have it fill out forms, you could have it do all sorts of stuff. So try this on a website and let us know how it goes, um, and come up with your own improved version of it. And sorry, I didn't see all the comments that were flying through because I was in the zone. But um, yeah, async stuff is just async stuff is always going to be fun, and um, anything with concurrency um, really just messes with your head. I just have fun with it. Yeah, cool. Yeah. Thanks everyone. I'll send out another email, and we're going to yeah, we're with a form where you can send in your findings for which website you decided to automate, and we're going to meet again one more time, making an even more difficult agent, and this is really the most difficult one that we can make. Um, and I I really don't know how we're gonna do it in 1 hour. I have no idea, but we're gonna try. We're gonna try and make a a computer use agent. So instead of automating just the web browser, we're going to actually automate an entire computer with a mouse, keyboard, everything. Taking screenshots of the computer as we go along. So that's going to be the final epic lesson that we're going to attempt. And yeah, who knows if we're going to make it. But I'm really excited to show you all what I've learned and yeah, how we can try. So yeah, thanks. Thanks, Mixer Canada, Raj, Nelstar, and Jordan for joining in, and Burhan and Jonathan, of course, as like it.
Awesome.
It was crazy, right?
The
Yeah.
way I see it is like, you know how web search APIs work?
Mm-hmm.
That helps you narrow down your approach with your ideas. So that's the way I look at it.
Say that again.
Like,
Explain a
you
bit
know
more.
how you know how web search APIs work,
Yeah.
like Perplexity and stuff.
Oh, like that. Okay.
Yeah. For me, like, to come up with an idea for this exact workshop, I
Mm-hmm.
would be looking at something close to that, like something that involves web search or real-time data.
Mm-hmm.
Helps me narrow down stuff.
Hmm. Okay. Yeah, something that needs web search or real-time data. Um, yeah. Um, and then you could find a way to read the data from the pages. Like for example, you were talking about archive.org. So you could have something that crawls archive.org looking for a particular paper and then uses that. That could be one use. Cool. Any thoughts, Jonathan?
Not not really. So
Cool.
probably in my scenario, what I would be thinking is to make maybe social there are these social bots. If
Uh-huh.
someone about needing your product, we can immediately just use like maybe a cron job to keep searching Twitter or Facebook. When
Yeah.
someone needs products, you can just directly sell to the person. Or when someone talks about a product that aligns with your product, you can just
Mm.
make cold call or cold email. So that would be what would come to towards my idea. So when the person talks about it, the agent crawls the person's profile and bring some sort of social engineering to you. This is complex, by the way, not as easy as it said. Yeah.
Yeah, it's hard to make it reliable with these tool use agents, but we're getting there. And I think
Yeah,
if you hard coded some of it, you could actually do that really, really well with you're talking about detecting mentions on social media.
yeah.
Cool. Nice. All right. Thanks everyone for joining. And we will see you on Friday for the last lesson. Thanks, guys.